Hey everybody, welcome to today's webinar. This is Jason from AV Pro Global. Today we're going to be talking about the Fox and Hound HDMI troubleshooting kit presented or manufactured by Murideo, one of our sister companies. My name's Jason. I am going to go through the slideshow with you today, and I've got a Fox and Hound here. I've got a set of extenders. I've got an AVR. I've got a source. So this is going to be kind of a live demonstration, if you will, on how to use the Fox and Hound to troubleshoot HDMI systems. This is the first time I've done one like this before, and I think I got everything set up here to where it should work out. So just I do ask that you just bear with me for a moment if I run into any hiccups here. I do have our marketing director, Tom Devine. He is watching the question box. If you guys have any questions during the presentation, he'll do his best at answering those. I will leave some time at the end for some questions if you guys do have any. With that being said, let's go ahead and get started. So I do see some familiar faces in the attendee box here. So thank you guys for coming back and checking out the webinar. If you're new to AV Pro Global, I just wanted to give you guys a quick heads up and a little brief history of who we are. So many years ago, 2011, 12 or so, we started off as an online distribution channel. And the company at the time was very young and trying to kind of find their way, and they saw a big giant empty hole in the market, and that was for test equipment for 4K and for HDR for 18 gigs. So as you guys can imagine, with that big void in the market as the technology was about to hit us, there was a giant opportunity there to build some product to be able to test this stuff. So Jeff Murray, our CEO rather, he comes from a very extensive background in electronics. He's worked for many electronics companies in the past. One of them being Sencor, which you guys may be familiar with if you've been in the test equipment game here now for a few years. A lot of calibration gear came out of Sencor in the early days of ISF. So with Jeff's background in electronics and working for these big test equipment manufacturing companies, Jeff's son Matt, our CTO, very driven, very smart guy. He knows HDMI very intimately. He's kind of the guy I go to when I have questions. He's very, very good at what he does and very passionate about what he does and very driven. He won the 2019 Dealerscope 40 Under 40. We're very proud of that. So congratulations to Matt on that. But that's kind of a little brief history of our company. Back in 2014-15, we actually put out the Murideo 6G generator, which you guys might be familiar with. First of its kind and still used every day today by lots and lots of calibrators, lots of manufacturers for testing, and lots of integrators for troubleshooting. Our goal as a company is really one thing. We want to keep things simple for the installers. We want your guys' lives to be easy. When you show up to a job and you've got a big problem on your hands, a big distributed system, and a couple TVs aren't playing, or they're playing the wrong resolution, or maybe there's no audio coming through. We wanted to build test gear for you guys to be able to walk in, plug in, push a couple buttons, and see exactly what's going on with the system to make the troubleshooting very easily. From test equipment, we got into manufacturing 18 gig extenders with HD-based-T, and from there we started getting into matrix switches and things like that, and now we're building all kinds of little fix-it tools, and we're deep into it at this point. Our technology is excellent. We have a lot of proprietary things. We have a lot of cool things that nobody else is doing. Our engineers are great. Our tech support is great. If you guys have ever called tech support before, you probably had a pretty good experience. We get lots of compliments on our tech support. And we're always looking into the future, just like we were ahead of the curve with HDMI 2.0 and 18 gigs. We're already developing things for HDMI 2.1 and 8K and 120 frames per second. We actually have 120 frames per second in one piece of gear already. So again, we're trying to stay ahead of the curve, and we're trying to keep your guys' lives as simple as possible. A little bit about me. My name's Jason. I've been with the company now for 3 years. I've been playing with this stuff for my entire life. I love it. It's one of those things. I'm one of those lucky guys who it doesn't really call this work. This is fun for me. I started calibrating about 12 years ago. That put me down to a really deep rabbit hole, which you guys, especially you guys that are on this webinar, can probably attest to. This is my life. I love this stuff, and my job is to be a resource for you guys. So as you have questions out in the field and things like that, of course, our tech support's a great place to reach out, and you guys can always email me if you have any questions. I'll provide my email address here at the end of the presentation for you, just in case. So why are we going to talk about troubleshooting today? Really, it's all about these numbers that you're seeing on the screen. This was a poll taken by CEDIA, and it was for integrators, and they were trying to figure out some numbers around HDMI installation and what kind of problems and headaches the installers were dealing with out there. So let's take a look at some of the numbers. So 66% of the integrators that were polled said that most installations involve HDMI. That's pretty straightforward. A surprising number is not actually higher, to be honest with you, but at least 66% of installations involve HDMI. 57% of the people polled said that HDMI installations require a great deal more time. As you guys know, HDMI, as much as we wish as it was plug and play, there's other things to worry about like EDID and HDCP and all kinds of cool things we'll talk about today. 49% say that return visits are more likely when HDMI components are involved. So this is a pretty staggering number. Half of your installations are more likely to have return visits. Those truck rolls I know are not cheap. I know the labor is not cheap. I know you know the headaches that you deal with the customers are not fun to deal with and not cheap. So that's pretty staggering. Half of your installs with HDMI return visits likely. It's crazy. 83%, huge number, 83% of installers said that they had to take steps to simplify installations that involve HDMI components. We do our AV Pro Academy classes all over the country, and I've heard installers in the past say, why can't we just go back to component video? It just works. And I understand that, and I sympathize with that. I was an installer myself for a little over 15 years in the field, and trust me, there was plenty of times where I wish I had some test equipment like what we're going to look at today with the Fox and Hound. But you know, once you know how to work with HDMI and you know how to troubleshoot it, and hopefully we'll get into some of that today and help you understand some of that today. It's not as hard as it looks. It's not as hard as it sounds. You know, when you're having a problem with HDMI, being able to plug in an analyzer and push a button and see exactly what's coming down the pipe gives you a lot more knowledge and about what's going on in that signal chain and that signal, so you can troubleshoot from there. And then last but not least, another huge number, 82% of installers had to remove HDMI components to make them work, meaning they had to remove HDMI product or switch over to another type of connector just to make the system work. That is huge, guys, and this is why we do this. These numbers, you know, if everybody had this test equipment, I would bet these numbers would be significantly less. So let's talk a little bit about troubleshooting and why it's so important to have these tools. Okay. So why is it important to have this toolkit in your toolbox in your van? Number one is to troubleshoot HDMI distributed systems. That's the main point why we're here today. You know, customer calls up and says, "Hey, the kitchen TV is not playing," or "I get sound but no picture." You need to be able to walk in and troubleshoot that quickly and efficiently without spending hours and hours there on site. We are going to use these tools to ensure bandwidth and to confirm that the EDID is correct. EDID synchronization is about 80% of the failures that we deal with at tech support. So, you know, 9 times out of 10, or I'm sorry, 8 times out of 10, somebody calls up with a problem with HDMI. So it's 80% of the time it's EDID related. We also have to validate HDCP 2.2 compliance. If anybody has been around for a long time, when we went from HDCP 1.4 to HDCP 2.2 a few years ago, that caused a lot of headaches in the field. So we want you guys to be able to use these tools to validate HDCP and to confirm that a product that's passing a signal through can actually handle that HDCP 2.2. And we see this a lot in older components. So maybe somebody has an older AVR that they just really love the way it sounds, they love the way it works and looks and whatever. You know, that might only be HDCP 1.4. So we got to figure out what's compliant, what's not, and figure out ways around those things. We need to provide a reference 18 gig signal to the architecture and to the components and to the display. When I'm setting up a display for the first time, if we're doing a class, for example, I'll usually use an analyzer to make sure that the infrastructure is correct before we start taking TVs out of the box. If my infrastructure is good for 18 gigs, I validate that with my test equipment. Then it's safe to go ahead and start connecting everything and getting everything powered up and getting ready for the class. So imagine instead of a classroom environment, what I'm dealing with a lot these days, you're dealing with a home where there's multiple displays. If you can put the analyzer in place of where the display is going to go and validate your infrastructure before the TV goes up, that can save you a lot of headaches in the long run as well. Again, I'm going to mention this many times, so I apologize in advance for the repetition, but it's all about avoiding truck rolls. In my days of installing, you know, we would sometimes go out to a customer's home to do a troubleshooting call, and sometimes it would take 5 minutes and sometimes it would take 5 hours. Whatever that case is, we want you guys to avoid those things, because the truck rolls, especially if you're not getting any revenue from that, it can be very expensive and a drainer to your bottom line. And then on top of that, guys, it's just peace of mind. You know, if you're installing a big complicated system, sometimes it can be a little overwhelming with all the components and the signals and the different types of displays and maybe different capabilities of the displays and the sources. You know, you can install this stuff with a peace of mind of knowing, hey, if I do run into any problems, I've got some tools here that are going to help me figure this out, and I've got a tech support department at AV Pro that's going to help me out as well. You know, a lot of times what we see in systems is that, you know, somebody without test equipment will call up and they'll say, you know, hey, we've got this one TV in the bathroom that's not giving us a picture. And one of the first things that we ask them is, do you have test equipment? Because from a troubleshooting standpoint, from a tech support standpoint, you know, if we can walk the integrator through, you know, plugging these things in, pushing some buttons and figuring out what's going on, you know, these tech support calls go from, you know, an hour more down to a few minutes sometimes. So, you know, we want you guys to have these tools. We want you guys to use these tools when you call us. We just want to help you. What we really want to avoid is this right here. It's the old what we call the pluck and chuck method. And you know, I've done this in my career before, especially before I had test equipment to deal with. But you know, it's always, you know, you walk into a system and the TV is not showing the resolution that you want, so you immediately start replacing things. Maybe it's the source. Okay, you replace the source, you come back, you plug in a brand new source, same model number, same everything, and you still have the same problem. So okay, now it's the TV, so you replace the TV, you have the same problem. Okay, now it's this HDMI cable, you replace that, it's the same problem. So we call this a pluck and chuck method. We don't want you guys to do that. It's a giant waste of time, a giant waste of resources. You know, if you decide to replace the TV and it turns out the TV was okay, now you're stuck with inventory of an open box TV that you didn't need in the first place. So it's a big waste of time, it's a big waste of resources. We want you guys to avoid those things. Again, saving money is what this is all about. Saving those truck rolls, saving on repeat visits. We also want you guys to identify system shortcomings. And what we mean by that is, if you do have that person that has that older AVR, you can test the AVR for HDCP compliance or for 18 gigs before you even you know, talk about maybe replacing it. So if you find a shortcoming with a system, maybe it's infrastructure or a specific product or whatnot, you can identify that on the front end and talk to the customer about, you know, ways to go around it, or maybe just replacing, you know, whatever that product is. And then to verify compatibility of system components. Again, if I'm putting in a 4K HDR system, I want to make sure that every device in that system, including the HDMI cables, can pass 18 gigs, 4K HDR, all the good stuff. You know, that could come down to cables, extenders, and every little bit and piece that goes into that system. So a few features that we want to cover today. We're going to do a cable test. I've got a couple cables here that I'll show you how to test those. It's very easy. It's very straightforward. Again, that's kind of our whole philosophy, is to make it easy and straightforward. We're going to talk a little bit about setting up displays and looking at different test patterns to verify that 18 gigs is getting through. One of the big things right now that people are talking about is 4K 60 444. You know, that's a huge thing right now. There's now a couple of movies that are doing 60 frames per second. So validating that the system can handle the 60 frames per second, validating that the movie's going to play correctly, that's super important stuff. I mentioned this once already, HDCP testing. If I've got an older product that can't pass HDCP 2.2, I'd much rather find out, you know, on the front end versus in the middle of the installation, or God forbid after the installation is done and all of a sudden you have no picture because this AVR is a little bit too old to pass HDCP 2.2. We also have to test for HDR. Just because a product says that it's HDR capable doesn't necessarily mean that it does Dolby Vision, for example. So if a customer is really interested in Dolby Vision technology, you know, we want to be able to verify that that all the components in the system can handle Dolby Vision. Also, EDID, huge thing right now with EDID, something that we never really had to worry about up until a couple of years ago. But being able to read the EDID from a display or from a repeater device, being able to read that EDID is gonna help you set the system up correctly and help you troubleshoot. Another cool thing I like about the Fox and Hound kit, it is portable and battery operated. You know, if I charged mine this morning, I would expect them to last at least 3, 4, 5 hours today. That's the general consensus that we hear from the guys in the field. So they're easy to carry around. They're small. They can fit in your pocket, even if you have maybe one of those front shirt pockets or whatnot. So we kind of live by this 5-step troubleshooting process. This is sort of these are kind of the steps that we start with from a very high level, at least with tech support. The first thing we're going to do is start at the source, and we're going to inject the signal through the system that we want. So if I take my generator here and I set it to 18 gigs, I put it in place of the source. If I don't get a picture on the other end where the display is at, then I know that something's going on in between the source and the display, or the infrastructure at least. Once I start at the source, then we're going to verify picture on the display, like I just mentioned. Maybe next in the signal chain after the source is an AVR. So I'm going to plug the generator into the AVR, and I'm going to pump that signal again, the same signal again through the system. And if I'm getting picture on the other end, then I know the AVR is passing the signal correctly. We're going to rinse and repeat this method, you know, depending on how many components are in the system. And think of everything that you might be dealing with in a system, guys. You might have You might have a source, you might have a repeater like an AVR, you might also have an extender. So you have a transmitter on one side, then you have a receiver on the other side, and then you have the TV itself. So you want to be able to take this generator starting at the source and pumping signal through the signal chain or through the system to make sure that everything is coming out on the other end that you want exactly. Now, if you do this method, starting at the source and working your way up towards the display, it's going to be very easy to figure out just by process of elimination which source in the system is giving you all these problems. So that's a good method that we start with. If somebody calls us up and they say, hey, I don't know what's going on, I've got no HDR on the projector in the other room, but my source is set to HDR, then we can take this generator, set it to HDR, and start going component by component to figure out what's going on with the system. So give you a quick overview on the Fox and Hound kit itself. It's going to come in this nice kind of flight-approved hard case, sort of a Pelican-like case. It locks. It's got a nice foam cutout here where your Fox and Hound are going to go, and of course your power supplies that you use to charge. Oops, sorry, I'm backwards here on the camera. So this is nice and foam injected, so it all fits nice and good. You can lift this piece up here. On the bottom, you've got some empty storage space here for maybe some adapters or some HDMI cables, or maybe a USB cable. These guys have USB on them as well. We do things like firmware updates with the USB connection, so there might be times where you need USB. The kit itself is composed of two pieces. The signal generator on this side, that's what's going to put signal through the system. It's going to go in place of the source or maybe the repeater device. And on the other end, you've got the analyzer, which is going to bring in a signal and tell us what's going on. There's a live preview screen right here, which is really cool. So if I plug in, for example, a source device into the analyzer, I've got a stack of gear over here, a couple streaming devices, an AVR, Blu-ray player. If I power up the Fox and Hound, if I power up the analyzer side with the HDMI cable plugged in, I've got signal going on the other side here, and I push the info button, and right now, here we go. I've got no signal. So something's going on with my source right away. Let me try to fire the source up, and if not, we'll come back to it. No big deal. It may have gone into a standby. Oh, nope, there it goes. Okay, so I've got my source back right here. So I've got my source plugged in. I can see exactly what's going on in the source. I've got a live preview screen, so I know I'm getting picture. If I push this info button right here, the info button is going to show me the resolution, the frame rate. It's going to show me everything I need to know about that signal. So when I push the info button, I've got frame rate, I've got resolution. I'm sorry if this is not focusing for you guys. I was really hoping it would. But I can see things like how much bandwidth is coming through. So in this particular case, it's 3840 by 2160 at 60 frames per second. The color space is 420. The video type is, of course, HDMI. The color depth is 10-bit. I've got HDCP 2.2 with HDR present, and that gives us, so with 4K 60 at 420 at 10-bit, the bandwidth is 11.12 gigs. So I know exactly what's going on with that signal as it comes through the system or as it comes out of the source. Very, very helpful when you're trying to troubleshoot. If you're not getting HDR on the TV, but it does say there's HDR coming out of the source, then obviously something in between the source and the display is causing this issue. And that could be something as simple as an HDMI cable that can't pass that much bandwidth. It could be a setting on an AVR or on a repeater device. It could be an EDID setting on the AVR that's not letting the it's not asking the source for 4K or HDR. So there could be a couple things going on here, and that's really what the point of this all is. Now, one of the easiest things you can do with the Fox and Hound kit is test your cables. This is huge, and this is so easy to do that if I'm an integrator and I'm about to go to a job where there's maybe 20, 30 HDMI cables that are going to be in the system. I might take some time the day before or that morning or something, or maybe I've got somebody in the office or in the warehouse that can do this. But if I take this HDMI cable is what's going to go into this system I'm about to install. Check out how simple this is. I'm going to take my two ends. One end is going to go into the analyzer, of course, and one end is going to go into the generator. Okay. Now the generator and analyzer both powered on, which they are now. I'm going to take the analyzer And on the analyzer, there's a button right here that says cable test. So I push the cable test button, and I'm going to pick a resolution or a bandwidth. The very top option there, if you guys can read that, is 2160p 60, and in parentheses next to it, it says 18 gigs. So I want to test this cable for 18 gigs. So I press the cable test button, and then I press OK, and the Fox and Hound is going to test this cable for me. What I hope you can read here, and maybe not because my camera is having a hard time focusing right now, I've got a few lines I'm looking at. The first one's the 5 volt. The 5 volt says OK, which is great. That means there's a communication between the generator and the analyzer. So we at least have that going. Next to that or below that is data channel 0, 1, and 2. Those are the TMDS lines inside the HDMI cable. The TMDS lines are what's carrying the audio and the video, all the good stuff. So in this case, it says data channel 0, 1, and 2, 0 errors, 0 errors, 0 errors. That's good. That means the AV is good. After that's the DDC channel. And after that's the hot plug, and they say pass and pass. So now I can take this cable with 100% confidence, and I can go ahead and bury it inside the wall or in my conduit, or I can go ahead and install it into the system. And now the cable is going to pass exactly what I need to. So this is something that you can do beforehand, save some time on the front end. You'd be surprised what happens sometimes when you have, a stack of HDMI cables. You'd be shocked sometimes to see how many of them fail from the factory. It's not something that's that we celebrate by any means, but it does happen. So again, if you do this testing beforehand, it's one less thing to worry about once you get on site. Okay, so I kind of just covered this before. We probably don't have to spend a lot of time on here, but this is just kind of a wiring diagram. If you can kind of see what's going on over here, it's HDMI from generator analyzer. The results are pass fail. It's very simple. I kind of talked about this stuff before. The 5 volt OK means that there's communication between the two. The 0 errors on the TMDS lines, that's of course going to be a good thing. If the cable is bad or if the cable fails, sometimes you'll see a giant number of errors on one of the TMDS lines or all the TMDS lines. One of the HDMI cables we have in AV Pro Academy, it's got a really nice big like slice or nick in it. And that all 3 TMDS lines fail on that cable. So you're looking for 0 errors there. You're looking for the DDC channel to be okay. The DDC channel is what's carrying the EDID and the HDCP and all the data and all the protocol stuff. So you want the DDC channel to be okay, of course. And then the hot plug detect is just making sure that the source and the sync device, or in this case the generator and the analyzer, have a solid communication and that there's not gonna be a signal dropped or anything like that. So that's sort of how you read those 2 screens. It's super easy to do. And at the end of the day, you just want to plug the cable into the generator analyzer, push OK, pick your bandwidth, and then just look for OK, 0 errors, 0 errors, 0 errors, OK. And if you get all 7 of those, I think that's 7 of them. If you get all those correct, or if everything's working correctly in the cable at least, then it's okay to move on. So pre-installation, this is what I was talking about before when we set up TVs for classes or if I was setting up multiple TVs in a home. Before I even install the product itself, I can take the analyzer and I can put it in place of the source. I can put the generator and put it in place of the display. On the analyzer itself, the generator itself, here's a cool little trick you can do. Once I power up the generator, you'll notice up here, one of the buttons says 18 gigs. I hope you can read it, maybe not, but it's the upper left button on the generator. So if I press and hold that 18 gig button, that's gonna kind of max out all of the parameters for 18 gigs. So it's gonna give me 4K 60, 444, it's gonna give me HDR, it's gonna max out everything. So, if I just by pressing and holding that 18 gig button, I can already start testing my infrastructure. Now, the hope is on the other end on the analyzer. In this case, it shows a set of color bars. Actually, give me just a second. I might be able to help here with the lighting. Maybe, let's see. Maybe that helps, perhaps. No, that's okay. But what we're seeing on the screen right now are some color bars, and I can toggle through. I do have a couple of other test patterns I can use, but the color bars are super easy. You see color bars on the other end, the signal's good. One thing I do want to point out here too is this is also an audio test tone generator. So you can listen for there's just like a really a solid kind of high pitched test tone that you'll hear come through your speakers. That's just validating that the audio is coming through as well. And you can always mute that in the generator, which is nice. But what's also cool in the generator, if I'm testing the audio, I can toggle between mute and 2-channel and 8-channel. So if I'm testing a surround sound system, 2-channel system, whatever the case is, I can certainly do that. Okay, cool, very good. Okay, so one thing that we like to do during the pre-installation, so maybe you're not getting the signal that you want. So if I start off maxing everything out with that 4K 18 gig button just by pressing and holding it, if I'm not getting signal, then the first thing I'm going to do to try to figure out what's going on is I'm going to knock down the resolution. So next to that 4K button, there's other buttons that say 1080, 720. There's one down below that says SD for standard definition. There's another button for VESA for different maybe PC resolutions. So if I press and hold that 18 gig button and I'm not getting signal on the other side, the next thing I'm going to do is press the 1080 button, and I'm going to knock that resolution from 4K down to 1080, and then I'm going to check the other side. So if I do get picture on the other end at 1080p with HDR, then it really tells me that something in between here and there is having a problem handling all that bandwidth. So then I can start investigating from there. Maybe it's my HDMI cable, maybe it's the repeater device in the middle. So when you start off with a maximum resolution, if things aren't happening the way you want them to, just start backing off on the resolution. Eventually, when you get down to 1080 or 720, unless there's some other very critical thing that has failed in the system, you should start getting a picture. And that'll kind of help you too also determine what the capabilities are of a display maybe. There's lots of displays out there from about 2013 and 14 or so that were 4K with no HDR. So in some cases, you might pump a 4K signal through to a 4K TV and not get a picture until you turn off the HDR, and then all of a sudden you do get a picture. So starting off with the maximum resolution and maximum bandwidth and kind of backing off from there is kind of the method that we like to practice. This is just sort of a wiring diagram of what we just talked about. The generator is pumping through a distribution system. In this particular case, it was coming out of the generator 4K, 24 frames per second. On the other end, we were getting 1080, 60 frames per second. So something in between here and here was giving us a problem where the resolution was being knocked down. Now, maybe something in this distribution system, maybe the EDID of one of these components in between point A and point B, one of these components might be a 1080p EDID, and that happens a lot of times. And why would a manufacturer for a display especially have 1080p as the default EDID? Well, it's safe. So, if somebody plugs in a cable box or something that can't do 4K and the EDID for the TV is 4K and the customer has no picture, the first thing they usually do is call the integrator or return the TV to wherever they bought it from. So a lot of display manufacturers and even AVR manufacturers will have these really safe low bandwidth EDIDs from the factory. So it's the integrator's job to go into the display and turn on enhanced format or turn on deep color, or maybe it's just a matter of certain inputs can handle 4K HDR. Whatever the case is, on my personal receiver at home, you have to go into this kind of secret menu by pushing a couple buttons and change the EDID from number 1 to number 2 or standard to enhanced. I forget their terminology, but once you flip that EDID switch in the AVR, in my case at least, then the EDID for the AVR is asking for 4K 60 with HDR. So again, just some basic things to kind of get you up and running here, to kind of help you out. For HDCP, it's kind of the similar story. If I take the generator on my side, let me go ahead and fire it up. Now, what will happen a lot of times, if I'm, remember with HDCP, it's copyright protection. So it's going to be for things that are streaming, movies that are made in Hollywood and whatnot. This is going to be for content that you're buying and consuming and purchasing. When we're testing signals like this, there's nothing wrong with turning off HDCP, and I might do that sometimes. If I start with the generator on one end and I have the HDCP turned off on the generator, I'm going to get a picture on the other end as long as everything else is working correctly. Now, if I take my generator and I push the HDCP button, I have 3 options. HDCP off, which is where I usually start, and then I'll go to HDCP 1.4. Hopefully I still have a picture on the other end. If I do have a picture on the other end, I go to HDCP 2.2, and hopefully I have a picture on the other end. If I do, that means my signal chain and all my components in between can handle all versions of HDCP. So it's really that simple, guys. Now, if I turn on HDCP 2.2 and I don't get a picture on the other end, or I might get a fuzzy picture like what you see here, it kind of looks like what we used to see, we used to call static, when we used to see TVs with no channel. If I get that static look on the other end, that's almost always, and in fact, you can almost bank on it always being an HDCP problem. So if I do get a picture on the analyzer with 1.4 and I get static on the analyzer with 2.2, then I know for sure that something in between can't handle HDCP 2.2. Now, that could be something as simple as a firmware update. This happened to me recently. I was actually at a friend's house helping him install some new stuff in his system, and he had an older AVR that couldn't handle HDCP 2.2, at least from the factory out of the box. The good news is that I asked him when the last time he did the firmware update on the AVR, and he said, "What's that?" So that told me right away that we need to put this AVR online and get a firmware update to it. And sure enough, the firmware hadn't been updated on the AVR in like 5 years. And when the firmware update happened, all of a sudden HDCP 2.2 worked. So it's not like you have to get rid of the AVR in some cases or get rid of a component. In a lot of cases, you can just do a simple firmware update, and that should solve some of your problems. Some of you may remember a similar situation when Avatar came out on Blu-ray back in like 2008 or 9. It was a huge deal. Everybody ran out and bought it, but that was an HDCP 2.2 thing, and a lot of people's Blu-ray players were HDCP 1.4. So you'd pop the movie in, the trailer would play, the previews would play, all the warnings would play, and then as soon as the movie was about to start, it would say incompatible. So, you know, in those days it was a little different because we couldn't just put the Blu-ray player online and on the Wi-Fi to firmware update. In those days, it was like, it was very early. So we were talking like thumb drives and discs and very long Ethernet cables to plug into routers to update the firmware on these things. But that's all it is sometimes, guys. Sometimes it's as simple as a firmware update. So when you're troubleshooting the HDCP, start with the HDCP off and then work your way to 1.4, work your way to 2.2. And if all is well, then you'll get picture on the other end, no problem. If all is not well, you might get no picture at all. You might get a picture that flashes every 2 seconds, which is common. Remember, in the HDMI protocol, when you plug in the HDMI cable, it goes through a series of checks, and one of the very last checks is HDCP. Now, once the HDCP is verified from the source to the sink, the HDCP will re-authenticate every 2 seconds afterwards. So if you're having an HDCP problem, you might have a picture that flashes every 2 seconds consistently, or again, no picture at all, or you might get static on the screen like this. Those 3 things all scream to me HDCP. So again, it might be a firmware update, or it might just be, you know, worst case scenario, you might have to replace that product. Okay, moving along here. So your source devices, I've got one of those hooked up right now. Let's see, where's my analyzer? Where's this cable? So if I check my source device, and my source device says, you know, 4K 60 with HDR, you know, 444, 422, or whatever color space I'm working with, 8-bit, 10-bit, whatever the case is. Now, if I come over to my analyzer here, I've got my source devices playing. This isn't quite there we go. There's something going on here. The dynamic range of my camera is not good enough to pick up what's going on this screen right here, I think. So it's showing up probably as like a blown out white image to you guys. Sorry about that, but I do get a picture. It is the screensaver of the source device I'm plugged into right now. Now, if I push the info button on the analyzer, that's going to give me a series of different parameters and what's going on with the signal. So right now I've got 4K 60 at 420 with HDMI, no HDCP, probably because it's just playing a splash screen right now, with 10-bit video with HDR, and that's putting me at 11.12 gigs. So if I, for example, had this source device that's over there putting out 444 or RGB, and I look on this end and it's 420, then something in between here and there is taking my chroma from 444 down to 420, or it's converting RGB into YCBCR 420. So this tells me a lot about what's going on with the source. So now I can go back to the source, I can verify the output. If my output is what I want and I'm still getting this on the other end, then I can move on to the other device in the system. There might be an AVR in between like there is right now. So my suspect right now is the AVR in this particular situation. So just to show you kind of how easy that is to set up. Now, if I go straight into the source, I should get exactly what's the output of the source is set to. I should get that right here as well. Now, if there's something going on, then my suspect is going to be, first thing I'm going to check is probably a firmware update. If I'm not getting, maybe I'm not getting HDR on this side, maybe I'm not getting 4K 60, The next thing I might do is test this HDMI cable. So again, just by process of elimination, I can start with the source and I can kind of work my way back towards the display. Okay, let's see what's next. Okay, so if I'm testing my sync device, now that could be my display. I'm going to put the analyzer in place of the display, and I'm going to put the generator in place of the source device. So what I'll do here is kind of what I talked about before when testing bandwidth. If I don't know if this display I'm working with can handle 4K or not, the first thing I'm going to do is set the generator to 4K. And if I don't get a picture on the other side on the analyzer, the next thing I'm going to do is go down to 1080. If I still don't get a signal, the next thing I'll do is go down to 720. If I don't get a signal there, I'll go all the way down to 480. If I don't get a signal there, the next thing I'm going to start checking is chroma and bit depth. I might have a display that can't handle 10 or 12 bits, for example. That might be causing the no picture. So the first place I'm going to start with a sync device is the resolution. And you might run into those situations before, like I said, in a classroom environment where we're setting up classes. Sometimes we might have an older TV in the room that can't handle 4K, but everything else can. And one funny example that we always kind of joke about when we're all together is we have this 480p plasma in our training room still up in Sioux Falls. So, of course, we send 1080, 720, we send all these different resolutions through it, and it shows nothing until we get down to 480. So in a distributed system where one display is 480, the rest of them are 4K, we've got to come up with an idea now to figure out how are we going to get 4K to this display. And luckily, it's super easy. In this case, we take one of our AV Pro Edge scalers, our little SC1 or SC2 scaler. In this case, it had to be an SC2 because we were taking the signal down from 4K all the way down to 480. So that really saved us, because the other way to do it is to knock the whole entire system down to 480. We would get a picture on every single display in that classroom, but it's not going to be 4K. It's not going to be what we want. So, by troubleshooting, or not troubleshooting necessarily, but by validating the infrastructure before the installation, I know for sure that display can't handle 1080. Display can only handle 480. So now I can come up with an idea and get one of those scalers in the mix to help with the system. Okay, cool. This is what we just sort of talked about here with the display device. Just like you can push the resolution button on the generator, I'll show you a couple other things here too. I might as well just leave it turned on. I keep turning it off, but the battery is nice and full. So I'll show you a couple things here. Hopefully you can kind of sort of see this. If I push the 4K button, that's going to give me all my different resolutions and frame rates in 4K. So I've got 60 frames per second, 30 frames per second, 24 frames per second, and I've got some DCI resolutions here too. So like 4096 at 60, 4096 30, 4096 24. Now that's for resolution. What if I want to change the chroma or the subsampling? I can push this color button. I've got, if you can read it, I've got RGB full at 8-bit, RGB full at 10-bit, RGB full at 12-bit, and then YC or video, 420 8-bit, 420 10-bit, 420 12-bit, 422 8-bit, 444 8-bit, 444 10-bit, 444 12-bit. So I can toggle between all these different chroma options and figure out exactly what that display is happy with. Now this is also part of EDIT as well. So if I have a display that can take 444, it might not be able to take 444 until I turn on the deep color. All displays are a little different, which is really important. Some displays you have to be plugged into a certain input. Some displays you have to have a switch flipped inside the menu. Some displays you have to turn on something called deep color. They're all a little different, so you kind of have to learn which displays are doing what. If you're not sure, give us a call. We deal with this stuff every day as a tech support team. So if you do have a situation where you got a specific brand and you're like, hey, I'm not sure what I have to do to this this brand X TV to make the EDID for 4K 60, give us a call. Say, hey, I've got a blah, 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 model number, blah, blah, blah. What do I need to do? And our tech support's going to say, oh, you need to be plugged into HDMI 2 or 3, and you have to go into the menu and turn it on enhanced. We see this stuff every day. We get calls from you guys every day. We have all these things in the lab. We have every brand, every big brand in the lab, and even some smaller ones too. So if you're not sure how to do this or how to set up the display, you can certainly give us a call. We can help you out. So for repeaters, so right now, this will be interesting. I hope this works. I tested this before, and I've got a repeater device over here. It's an AVR. Now I'm using that AVR has an HDMI input on the front. It's called VAUX or Video Auxiliary, and I have it on that input right now. So if I take my generator, I have it maxed out at 4K 60 because I pressed and held the 4K button. I have it maxed out for 18 gigs. It actually comes out to 17.8 gigs. I'm going to plug the generator in. So now the generator is plugged into an input on the AVR. Now coming out of the AVR, I'm going to take my analyzer with this other little cable here. Now the hope is I'm on the right input. The hope is what's coming out of the generator on this side is going to show up here on the analyzer on the other side. And so far I have no signal. So if I press the info button, I've got no signal. So first thing I'm going to do is I'm going to go to the generator. I'm going to press the 1080 button and I'm going to try a lower resolution. So instead of 4K 60, I'm going to go 1080 60. Maybe that'll give me signal on the other end. If I don't, I'm going to take the HDR and turn that off, which it already is right now once I switch to over to 1080p. So now I'm at 1080p 60 with HDR off, which should be a pretty low bandwidth and should get my signal through this AVR. And I'm still getting no signal on the other side. So I may have to go back to the AVR and turn on that front VOX input. That might be the case. Maybe there's an EDID switch for just that input on the AVR. I got to do some more investigating. But this is the point of it though, guys. I put out a signal on the generator. I'm not getting that same signal. In this case, I'm getting no signal on the analyzer. So now I can go back to the AVR because that's the only thing I'm plugged into right now. I can maybe try another input on the AVR. I can maybe try an EDID switch. I can maybe even put in a little EDID minder if I needed to. But again, plug in, push a couple buttons, and you can kind of start to troubleshoot from there. Okay, I should have just pretty much covered all this now. In this case, this was the repeater device. Mine's an AVR here. It looks like it's a little 1x2 distribution amplifier. So we've got the generator in, we've got the analyzer out. We push the 4K button on the generator to max out the bandwidth and the resolution. We push OK on the analyzer, and hopefully we can see some info. In this case, we've got a color bar pattern on the generator, and we've got a color bar pattern on the analyzer. So in this case, this repeater device obviously is able to pass the signal no problem. But again, if it wasn't, I would go to my 1080 button and start bringing the resolution down until I did get something on the other side, or I would turn the HDR off, or I would lower the chroma subsampling. Once I lower something, I'm going to hit a threshold to where this repeater device is able to pass a signal, and I'll get a picture on the other end. Now, as you're doing this, one thing I do want to point out too, super important, and this is why the Fox and Hound kit comes with a couple of HDMI cables. You guys have to make sure that these HDMI cables are 18 gigs. If I'm trying to test the system for 18 gigs and you're using an older HDMI cable or a damaged HDMI cable even, that's going to bring the whole entire system down. So we do give you in the box with the Fox and Hound kit in that nice hard black road case, we do give you some really good high quality Bullet Train, our own brand, 18 gig HDMI cables to do some of this testing with. So again, it's really simple. Generator in, analyzer out. Max out the resolution. If you're not getting picture on the other side, start knocking things down one by one. I like to start with the resolution. You can do things like turning the HDR off. If you like to do that first, that's okay too. But start with the highest possible bandwidth and start working your way down. That's kind of the whole entire point. Okay, extenders. Okay, cool. So I actually have a set of I have an extender kit over here. So here's what I'm going to do. In the transmitter, I'm going to plug in my generator to the transmitter, which is this guy right here, this transmitter. I've got a cat cable in between the transmitter and the receiver. So the generator is going into the transmitter. The receiver, I'm going to take the output of the receiver and I'm going to plug that into my analyzer. Oops, did I get those backwards? Bear with me, guys. I've got a couple cables here. Okay, no, that's right. There we go. There's the right one. Okay, good. So now I've got the generator into the transmitter. I've got the analyzer coming out of the receiver. And I'm going to do the same thing that we did in the previous couple of slides. I'm going to press and hold 4K and max out the resolution. So now I've got 4K 60 with RGB, takes up a lot of bandwidth, of course, with HDR on, okay? So this is maximum bandwidth. Now on the other side, so the generator is showing me color bars, the analyzer is showing me nothing. okay? So this is telling me that this extender kit is out of bandwidth. So it's either not able to pass HDR, it might not be compatible with HDR period, right? But we might not know that. You know, maybe these things have been in the house for a while or in the job site for a while. Maybe it's an unknown brand. Maybe the customer did not take your advice and maybe they bought some extender kit off, you know, off the internet or something like that. You might not know, and that's kind of the problem, right? So if I go over here to my generator, first thing I'm going to do, this is just a hunch, I'm going to turn off HDR. So now I'm 4K 60 RGB, no HDR, and I've still got no signal on the analyzer. Hopefully you can see that, maybe not. Okay, so the next thing I'm going to do is take it out of 4K, and I'm going to go down to really low bandwidth resolution. Sorry, we're going to keep it at 1080, so a decent resolution, but I'm going to take the frame rate all the way down to 24 frames per second, which will save me a ton of bandwidth. So now I'm 1080p 24 with HDR off. Check it out on the analyzer. Boom, I've got signal. So what might be happening here, this extender might not be compatible with HDR. This extender might not be capable of 18 gigs period. If it's a little bit older, it might only be capable of 10 gigs. So if I'm 1080p 24 with no HDR, that puts me at like, that should put me at 8 or 9 gigs, somewhere right around there. So this extender kit's able to pass that. So this tells me if I'm doing a high bandwidth 4K HDR system, I cannot use this extender kit. I need to be able to put in something that can handle that kind of bandwidth. Of course, you can take a look at our AV Pro 444 stuff for our extender kits, and those all can handle that bandwidth, no problem. So super easy. Input, output, start with the highest bandwidth and work your way down. Cool, I just kind of talked about this stuff here. I told you about toggling the HDR off and on. That's all good. I showed you how to do that. Cool, okay, we can move on. That's great. Okay, now for troubleshooting HDR. This is where people get into a lot of trouble. HDR can be your friend, especially if it's done correctly and set up correctly. I've set up so many systems for people in the past 2-3 years where they see HDR for the first time and they're completely blown away. And I'm like that myself. I mean, I still, I'm looking for every piece of HDR content I can possibly find, whether it's streaming or on disk or whatever. It spoils you quickly. And once you see it, you look at 1080p again, and you guys may be able to attest for this if you've seen it before, especially if you're living with it at home. You know, if I'm watching HDR at home and I go to a friend's house and they have no HDR, I kind of wish I was back in my house again. So if done correctly and set up correctly, HDR can be your friend. What you do want to do though is start off with maximum bandwidth. We have to make sure that the system can handle 18 gigs. So that's setting the system up for 4K 60 444. That's going to get us 18 gigs. Now, we also want to be able to deal with different compression methods and different, I should say, chroma subsampling methods. You know, 444 is uncompressed chroma, which is great. It does take up a lot of bandwidth. So in a lot of cases, you might have a device that outputs 422. You want to be able to test for that as well. So with HDR on, you should test at least 4K 60 444, 4K 60 422, 4K 24 or 30 at 444. If you test these three and everything passes, then it's pretty safe to say that that system can handle HDR and can handle all the bandwidth that you need. What you have to be careful of, though, is that if you're working with Dolby Vision, all the devices in the system, you know, because Dolby Vision is an end-to-end solution, every single device in that system has to be able to pass Dolby Vision. So I was dealing with a customer, an end user actually, about a year or two ago, and he had a particular AVR that could not do Dolby Vision, but his source could and his display could. The good news is, at least, is that in that particular case, he would still get the content in HDR. It just wouldn't be in Dolby Vision, but he really wanted Dolby Vision. So, you know, being able to test for it, being able to verify for it, what we found out right away is I plugged the analyzer into the output of the AVR, and I did have an HDR flag, but I had no Dolby Vision flag. Now, in that particular case, it was kind of interesting. That particular manufacturer did offer Dolby Vision after a firmware update. So we did a little bit of research and looked up the product on the manufacturer's website, and sure enough, it said right there in the one of the first things it said in the product on the product guide was if this product was manufactured before whatever date, you must do a firmware update, you know, to get Dolby Vision. So Again, luckily in that case, it was a simple solution where we just had to do a firmware update on the AVR and it did Dolby Vision, no problem. But you might get stuck in a situation where that particular product doesn't do Dolby Vision. So, that's a conversation to have with the customer. If you really want Dolby Vision, we've got to get this AVR out of here, and we've got to put something in that can handle it. So just about Dolby Vision, HDR, it's open source. You're not going to run into that problem with regular HDR. I just mentioned this before. If the system can handle those three different formats that we just pumped through, your system is stable enough to handle those high bandwidth signals, no problem. One thing I do want to point out here too, because this gets people in a lot of trouble, you will see, so it's very common for a movie or specifically a disc. So we know that most movies are done at 24 frames per second. There are a couple movies that are done at 60 frames per second. Some video games might be 60 now. What we do see sometimes are like TV shows or concerts maybe that are 4K 30. Now it might be 4K 30, 420, 10-bit on the disc. That's extremely common, but it's that specific set of parameters is not something that a lot of TVs can handle. In fact, most can't handle it. And I think we actually put in the verbiage here that almost no sync device can support this. So don't be tricked by 4K 30, 420, 10-bit with HDR. That's only 9 gigs, but you still might not get a picture on the other end. You want to take this down to 24 or up to 60, turn the chroma back into 444 or even RGB, or maybe knock the bit depth down to 8 even, turn the HDR off maybe. If you do set up these parameters on the generator, you might not get a picture. And depending on the firmware you have on your generator, if you have 4K 30 chosen with 420, it might not even let you pick 10-bit because it knows that the system or the display device isn't going to be able to show it anyway. So just be careful of this specific resolution. We've had people call tech support plenty of times and say, hey, I can't get this resolution to work. And we change just one of these parameters to something else, and all of a sudden it does work. So just be careful there. Also with HDCP 2.2, I think we talked about that plenty of times. If the system can handle HDCP 2.2, it'll definitely handle 1.4. The problem is if it only handles 1.4, it won't handle 2.2. So you got to be careful there. And I did mention this before. HDR is your friend, guys. If you do get this set up correctly and you do get it working correctly, you're going to blow your customers away. You guys have probably already done that before. These HDR TVs have now been out for a couple of years, so you're probably already getting that wow factor from your customers. And like I said before, if you're living with this at home, this is a pretty awesome technology. And just getting it to work right is, we're still in the early days of it, guys. I mean, these HDR TVs and sources and all this stuff about high bandwidth, of course, now we're ramping it up into 48 gigs with HDMI 2.1, but we're really just getting started here. Okay, a couple things on EDID, and then we'll be done for the day. EDID was almost a non-issue a couple years ago. You plugged the thing in, it turned on, you got a picture, you got sound, everything was great. EDID comes from the PC world, actually. It was a thing that they decided to implement years ago when we had, video cards had all kinds of different resolutions. Monitors had all kinds of different resolutions. So they implemented EDID into the PC world many years ago. And now because we have the same thing in video, we have to be able to understand what EDID is and how to manage it and how to work with it. So real simply, what is EDID? If you guys don't know what EDID is, it's just very simply, it's a communication protocol between HDMI devices. The EDID lives in the sync device. So whenever I say sync device, I know I've said that a lot. I hope everybody knows what it means. Real quickly, I'll cover it. The sync device is where all the signal goes into. So the sync device is most likely going to be a display. But if you have a repeater device in between, like maybe an AVR, the AVR has an input. So the AVR does also have an EDID. The EDID lives in the sync. It does not live in the source. And that's it's a big thing that people misunderstand all the time. EDID is only one-way communication from the sync device down. The job of the source is to read the EDID and say, oh, you want 4K 60, that's what I'm going to send you. Or the EDID says, I'm 1080p 60, so that's what the source will send. So you got to be able to understand how to test the EDID and how to see exactly what's going on. So let's take a look at the EDID on my source device here. So I'm going to take my analyzer and I'm going to plug my analyzer in to my AVR, which has an input. Now, what's really interesting about this, you'll notice on the analyzer, on the very bottom of the navigation buttons, there's a button that says EDID copy, the down button. So I can do one of two things here. where it says EDID copy, you'll notice there's A and B buttons where these lines kind of draw to. So what I'm going to do to copy the EDID actually is press and hold the A and B button at the same time. Once I press and hold the A and B button at the same time, a message comes up and says copied EDID. Copy EDID to buffer A. So now this analyzer is now mimicking that AVR. So if I'm troubleshooting the system, I can now walk around to the other room. Maybe I'm halfway across the house or something, trying to troubleshoot a TV. Now I can copy the EDID of that AVR into the analyzer, and I can run this analyzer back up to the TV, and I can plug in and start figuring out like where the EDID mismatch is. So what happens a lot of times is you end up taking a source device out of the rack, and you take a display device and you carry your source over to it, and being able to copy the EDID in the analyzer like that eliminates that altogether. So you can also do this with a TV. So maybe a TV is way up in another room in the house. Maybe it's in a kitchen or something like that. I can take the analyzer, I can copy the EDID of the TV to the analyzer. Now I can walk back to the rack with the analyzer, and now I basically have that TV right here in my hand. So from the rack, I can start plugging in sources into the analyzer with the TV's EDID to figure out where things are falling apart. So a lot of people will carry around a little test monitor. That's really cool. It's better than nothing, but you have to remember that those test monitors have EDIDs as well. So that might throw you off. You might get a false positive, or you might think things are right when they're really not, because the source device is now responding to the EDID of that little test display. So ideally, you want to emulate the EDID with your analyzer and then walk back to your source devices and start checking things from there. Okay, cool. I think most of this I just covered. Repeaters always sometimes spoof the EDID. Okay, this is cool. This is easy. Oh yeah, you could also do this too, which is nice. There's an auto button here on the analyzer. So if I push the auto button on the analyzer, on the generator, let me start over on that. The generator has an auto EDID button on it. So if I put the generator in place of a source device, it doesn't matter what I set my generator to as far as output goes. If I push the auto button, it's going to respond to the display device or to the sync device and tell me exactly what's coming out of that, or what's going on with the EDID. So in other words, if I take this generator to a display and push auto, the generator is going to let me know what the EDID is of that display. So I can do this two ways now. I can auto EDID and read the EDID from the display and see what the display is asking for, or I can emulate the EDID with the analyzer and walk the analyzer back over to the source devices or to the rack and start troubleshooting from there. So doing the EDID management and trying to figure out the EDID of the source, of the display, trying to troubleshoot, you can really do it with either the generator or the analyzer. Just depends on which way you want to do it. But I would practice with it both ways and see what you like the best. Here's a pro tip for you. Here's something that we kind of preach in our tech support lab. We go with a little method we came up with called CCEC with EDID. We can copy the EDID. We can use what we call a canned EDID. What that means is a canned EDID in the analyzer, we do have a bunch of preset EDIDs as well. We call those canned EDIDs. So we can copy the EDID from the display. We can use some EDIDs that are already in. We can emulate an EDID. We can also create an EDID. So this is usually where things usually fix themselves. If I copy the EDID from a display, I can usually troubleshoot from there. If I use one of the canned EDIDs that's built into the unit, I can troubleshoot from there. Very rarely do we have to do things like emulate the EDID or create a new EDID, but these are the four things that we start troubleshooting with when it's EDID problems: copy, can, emulate, create. Okay, a couple of common problems and a couple of slides left, and we'll be all done for the day. We do have a guide online. I'll show it to you here in the next few slides. There's a troubleshooting AV systems guide that we wrote, and it's on the website. It's a guide that shows you like where to put the generator, where to put the analyzer, and what to do. I'll show you that in the next few slides. 4K, individually check that products can handle 4K. 18 gigs takes up a lot more bandwidth than 10. Our old threshold used to be 10. So you could have something as simple as 4K 60 not passing, but 4K 24 will. So be careful of that. Manage your EDIDs on the repeater. device or the sync device, and that could be as easy as using the right input, or that could be as easy as turning on deep color in some situations. Maybe you're getting incompatible video. Maybe the source is set to one resolution and the display is showing another resolution. Go ahead and take that analyzer, emulate or copy the EDID from the display, and come back to your source device and start troubleshooting from there. So just a couple of pro tips that we threw in there for you. Discolored video, this is something that happens sometimes too. We see this sometimes with Dolby Vision, with certain types of Dolby Vision. We see this mainly with a mismatch between RGB and component. So in some cases, if you have your source device set to RGB, your display comes up and it's all pink or magenta or green. It's just as simple as going back to your source device. Now, I don't know that until I plug in my analyzer and see. So if I get a purple or magenta or green screen, I can see video, but maybe it's all green. I can come back to the analyzer. I can read the EDID of the display. The display says that it wants YCBCR, but I take the analyzer and I plug it into the source device. It's putting out RGB. So I knew within a few seconds what was going on. So now I can switch my source device over to YCBCR, and now my picture's correct again without all that green or magenta distortion. Source problems, again, you can plug the analyzer directly into the source, find out what's coming out of the source, adjust your parameters from there. Sometimes it's not the same. We've seen that sometimes. We saw a Blu-ray player a couple years ago that regardless of what you set it to as far as chroma, it always came out 422 no matter what. So even if you set it to 420 or 444, it still came out 422. So in that case, we reach out to the manufacturer, we let them know what's going on, and they do a firmware update to fix the problem. So again, being able to test for this stuff and read this stuff is super, super important. This is the troubleshooting diagram. I kind of teased that before. In this particular case, we've got it looks like a multi-viewer with 3 sources and 2 displays. So this is a very common system. What I've got numbered here for you, and again, this is all available on the website. This matrix switch right here, the first thing we want to check is number 1 is the whole entire system. So is the whole entire system compatible with 18 gigs? Are these cables? Is this extender? Is this TV? Number 1 is going to be the whole entire system. Number 2 is the source device. So I can do a couple of things here. At the blue squares you see are generator test points. The red squares you see are analyzer test points. So if I'm testing the source, I can put an analyzer here before the switch and test what's coming out of the source. I can do that with all 3 sources. But if I want to test the infrastructure after the source, I can put a generator in place of the source. See, generators here, generators here. So if I'm testing the source, I'm going to use an analyzer here. If I'm testing the infrastructure and rest of the system, I'm going to use a generator here. Now coming out of the outputs, it's very similar, but just kind of the opposite. So I can take a generator and I can test the system from the switch on, or I can take an analyzer and I can test what's coming out of the switch. So either way, I can test going this way, or I can test what's coming out, or I can test what's going in. I can also test these cables. So, maybe these HDMI cables need to be tested. Maybe these HDMI cables need to be tested. I think that's what number 3 and 5 are for. And then number 6 and number 8, that's your transmitter and receiver. If I'm testing this transmitter, if I'm testing the receiver, I'm going to pump some signal. If I'm testing I had that right. If I'm testing the system up until the extender kit, I can put the analyzer last in the signal chain before the extender kit. Or if I'm testing what's coming out of the extender, I can put an analyzer on this side. Or if I'm testing the TV, I can put a generator on this side. Now the TV here, number 9 is the last cable. Number 10 is your TV here. Are you plugged into the right input? Do you have the deep color turned on? What does the EDID say? These are all questions that we're going to ask if you guys call us for troubleshooting. So again, having these tools is going to be a real big lifesaver. A couple notes. When troubleshooting, test one thing at a time. Take lots of notes. Sometimes I like to take notes on my phone or even write them down and go old school and use pen and paper. I've already tested this, I've already tested this, I've already tested this. If you're dealing with a big robust system like this, it's going to be very imperative for you guys to take notes of what you've already tested, what you've already done. If you're doing a really simple system where it's 2 sources, an AVR and a TV, you might not have to go too crazy. You can kind of keep track in your mind of what you tested, but I still recommend taking notes either way. Simplify your troubleshooting. Take one device at a time, and if you can, we've seen this happen plenty of times. Somebody has a projector, and they say, I can't get the projector to play HDR, but I use my analyzer, and there's HDR coming out of the source. Okay, great. Take the source into the room where the projector's at, plug it directly into the projector, and let's see if you get HDR then. If you do, then for sure that something in between the source and the projector is what's causing the HDR to drop out. So we could start going back and testing cables. We still could go back and start testing the outputs of the sources and the AVR and maybe a matrix switch. We could start looking at the EDIDs and reading the EDIDs of the matrix switch and maybe the AVR. One thing I do want to harp on, I do this quite a bit in the classes. Guys, 48 gigs is a ton of bandwidth. If you're doing this in a distributed system, you might want to consider fiber going forward. Fiber is going to take us into the future. That's what's going to be able to help us carry these really high bandwidth signals going forward. We can get so far with copper, but fiber can take us way, way, way beyond what copper can do. I mentioned this at the very beginning of the presentation. Test all your cables before you install them. The last thing you want to do is put a 50-foot HDMI cable in the wall just to find out that it's bad. I've seen that before. It stinks. So try to avoid that. This is a big one too. Run conduit whenever possible. You know, there's so many times where I've talked to installers and I've talked to end users, and they've got to tear their wall apart just to replace an HDMI cable that they put in 10 years ago, and now they need something a little more robust. So run conduit whenever you can, especially if you're doing a pre-wire. Conduit's going to be your best friend when you have to upgrade the wiring of the system in 10, 15 years. And just plan and prepare. It's just like cooking, right? If you do the prep work really well and you do your planning really well, you know, the system can go in a lot easier than you think. If you're making a big meal, it's really no different. Everything's in the prep work. So plan and prepare as much as you can. And with that being said, we're right at time. I apologize for going just a little bit over. I was trying to get you guys all the info. It's a lot to cover, I know, but I wanted to get you guys as much info as possible in the short hour that we had. If you guys have any questions, feel free to reach us avproedge.com, murideo.com. You can visit us there. We have a live chat box. Somebody from tech support or sales will answer your question there. You can always give us a call, 605-274-6055. Anybody who picks up the phone will be happy to help you get your system designed and answer any questions for you. If you don't have time for a phone call, you can always email us at info@avproedge.com. And if you have any specific questions for me, anything you think I can help you with, you can always reach me at jason@avproglobal.com. Good. Thank you guys so much. With that being said, let me take a look at the question box and make sure that Tom was able to get everything. Let's see. Chris, thank you for getting that song stuck in my head. I meant to say that to you before. Let's see. It looks like Tom was able to answer. Awesome, guys. Well, thank you so much. There were some great questions. It looks like Tom was able to get to all of them. If there were any questions that you think of later, again, feel free to email us or email me directly. I'm happy to help out. We do have several more webinars scheduled over the next 2 to 3 weeks. I think 3 weeks exactly. So feel free to check the website, register for as many as you want. I'll be doing some live calibration. We'll be doing some 8K stuff. We'll be doing some our new 7G generator. Just lots and lots of cool stuff coming up for training sessions. We know everybody's in a very strange position right now with working from home and things like that. So if you have any colleagues or coworkers that you think would benefit from taking these webinars and watching these webinars, you know, feel free to pass those links along. And thank you guys so much. Enjoy the rest of your day, and hopefully I'll see some of you guys tomorrow when we do 2 more presentations. Have a good night. Thank you.